open a drawing. I guess we're working in inches. We can work in inches or millimeters. It just depends on your preference. Okay, so that's the DXF part, which is great. Now we need to produce a thing called a profile, which is just a series of linked line and arc segments. So to do that, we hit the big red CNC button here. It shows us where our machining datum is, which is that blue propeller. If it's in the wrong place, then we can move it to somewhere else. So what we need to do is to produce this thing called a profile. So the profile will start from the front. Let's give it a width just so that I can see it. It's not an enclosed shape, so I need to give it an endpoint. And that just checks that the geometry is contiguous and that there's no gaps or overshoots or anything like that. So that's safe to take through into the machining software. So if I save that away as a PartMaster drawing, and then we'll take that through into the turning module. So this is where we decide how we're going to machine it and what tools we're going to use, etc. So the first thing is to check on our tool change position. So if we're working on a rear turret or a rear tool post or a front tool post, we can set up the safety or home positions here. The maximum spindle speed, if the machine is capable of constant surface speed, then we'd enter the maximum here, and a clearance distance here. So this is at the a measurement of where the tool will switch from rapid to feed rate or feed rate to rapid as it's moving towards and away from the job. Okay, so we start off with an empty file. In our tooling definitions window here, if we've defined any tools previously, then we can just import the tool file or make that happen automatically. The program operations down here is things like select tool number 1, face off, select tool number 2, turn, select tool number 3, finish, select tool number 4, part off, etc., etc. So to get any of those operations into play, we need to use the bottom toolbar here. So I'm going to define a tool. So this gives me the opportunity to define the tool type that we can use. So if we're looking at a standard turning tool, and if this is a CNMG tip, it's got an 80-degree included angle. If it was a DNMG, it would have 55, and if it was a VMB, it would have 35. So we'll stick to a standard 80-degree rhomboid, and that tool can either cut from the right or from the left. So if we need to do back cutting, we can do that. And this tool can be mounted on a front turret or a front tool post or a rear tool post or rear turret, and then the tool can approach from the front or the rear. So we've got complete control over where the tool is moving from and where it's mounted. So this will be tool number 1, and let's give it a description, and we'll call it rough turn, and we can give it a cut depth, and that will just display the size of the tool on the screen, but we can change the cut depth at any time, and we can change the cut depth on a particular operation as well. So that's 1/2 inch, so that's around about the tip size that is fairly standard. Okay, so that's defined that tool, so now let's select it for use. If we want to use constant spindle speed, we enter the spindle speed here, or if the machine is capable, we can enter constant surface speed. So let's have, say, 250 feet per minute, and then the direction of the spindle depends on how the machine is configured to run the spindle clockwise or counterclockwise, the maximum spindle speed that we can run up to, and then a feed rate can either be feed per minute or feed per rev. So let's have feed per rev, and if we need to use coolant, we switch that on here. So now that that tool is active, we can start the operations. So we might want to start off with a facing operation. So we give it the start and end points of the cycle limits. So this is the position where we want the machine to start and where we want it to end, and the cut depth in this case, make it say 0.125. So that produces a facing operation. If you want to animate the tool, then we can see that just coming in there. Okay, so we could use that same tool for a turning operation to rough out. So again, I'm giving it the start point and the end point. So that's, if you like, a rectangle which will encompass the working area. So that's the area I want to work within. It's an external cycle and we're turning towards the chuck. But in this instance I'm giving it a limiting profile, so it won't go past the profile which we created in the CAD system. If we need to leave a finishing allowance, we can do. In X and Z that can be a differential fin cut in there, and again the cut depth that we want to use. So that will produce a feed rate motion there. And what that does is when it comes into contact with the profile, it's standing off by the finishing allowance, but it's cutting back to the last position it left the component, so that there's no nasty steps or anything, so that the finishing allowance will be exactly what we want over the entire part. Okay, so that's created the roughing pass. Now we probably want to define a second tool, and this time we'll call it the finishing tool. Select that tool for use, set the spindle speed and the feed rate. So we probably want a slower constant surface speed. The feed rate might be okay, and we'll switch the coolant on. So now we're going to produce a finishing pass. So to do that we use the profile turning operation, and when we're doing that we can add an extra finishing allowance on to make this a semi-roughing pass or semi-finishing pass, but if we want it to finish then we just leave the finish in X and Z to be 0. We can approach and run off the part with a nice arc motion, so I'll get that to start machining at that radius there rather than coming back up the front face, and to do that I use the under the options tab partial machining. So I start from span number 2, so each one of the elements that goes to make up the profile 1, 2, 3, 4, 5, 6 and so on and so on and so on. So each one of those are numbered automatically, so I can either point to them or I can just type in the number, and then we'll finish that at yeah, that's fine. So this is the finishing tool. Okay, so that's left the tool away from the job, so the last thing might be to send that tool back to its home position. So we use go to, send the tool to home position, but I want to move in the Z axis first so we know that it's clear of the front of the job before it does any rapiding in X and Z. Okay, so that's produced that part. Before we post-process we'll run the simulator using a standard lathe. So the simulator data is created, and then we can just look at the two tools that we've got. There's lots of things we can do here, but in most cases we can leave all of these defaults as they are and just simulate it. So this is the machine tool simulator with the first tool loaded. We've got simple video controls at the top here, so if we just run that, that's facing off the part. Now it roughs out towards the chuck. We can set up the billet sizes here, but if we don't do anything with that, then it just creates a standard billet size based on the sizes that the tool is working between. In the top right hand corner you can see a list of the feed rate movements, the rapid movements and any circular movements. So now comes the finishing tool, shows it to us in a different colour, and that's that. If we want to, we can move, zoom in and out and see any features that we like. So when we're happy with the simulation, we close that down, back to the main window here, and we post-process that. And in this case I'll use a Haas machine. Sorry, I just switch on the tool center line before I post-process that. Okay, so that's produced the G-code file, which we can send down to the machine tool. Okay, so that's how we can import a DXF file and then just machine it.